Hi, everybody. This is Mr. Folly, and welcome to 8.1 Solubility Curves. Okay, so let's hop to it. So, solubility curves. So, remember when things dissolve? So, if I have like a little beaker of water and I throw in some salt, it'll dissolve. And it kind of disappears. Woo! And really, it fits in the spaces between the water, so that's good. And we have a couple of things we're going to talk about. So, that's dissolving, right? And there's 3 levels of dissolving we're going to look at on the solubility curve. So if I did this and these things all dissolved and they floated in there and you'd be like, oh yeah, isn't that wonderful? And then if I had some on the bottom, do you see how this would be undissolved? Right? And the reason why it wouldn't dissolve is because it would be full. Okay? So the word saturated is like a real word that you should be comfortable with. So I like to talk about sponges being saturated. So right now, they're your old friend SpongeBob SquarePants, right? So if I had a thing of water and I stuck in SpongeBob, and what happens is I end up with SpongeBob and there's no water left, right? Then that won't work. But if I stick a sponge in it and there's water left, right? You stick in the sponge and it doesn't go in there, and there's water here, that means my sponge is saturated. So what does saturated mean? Saturated means full of solute. For this part, it'd be full of water, but full of solute. So if the solute mass is on the line, the solution is saturated. That means full. If the solute mass is below the line, that means it's unsaturated. That means unfull. If the solute mass added is above the line, then the solution is saturated with the excess solute on the bottom. Okay, so that means the same thing as full. Only if you are told the excess solute dissolves is a solution supersaturated. This is a trick. Okay, gases have a negative slope as the temperature increases, and solids have a positive slope. So just to show this quickly, this is a solid. This is a solid as they go up, and H3 is a gas because it's going down. SO2 is a gas because it's going down. Okay, I'm going to erase those. Where's my eraser button? There it is. Okay, so that's what that means. And then when changing the amount of solvent, so see how this is out of 100 grams, set up a ratio to determine the saturation. All right, so let's do these. When 90 grams of solute and placed in 100 grams of water, is it saturated, unsaturated, or supersaturated? So 90 grams of solutes, that's going to be over here. I'm looking at 90. In 100 grams of water, so not anything crazy, at 40. Here's 40. Here's 90. I'm looking at this spot right here. Is placed in 100 grams of water at 40. If it's KNO3, here's KNO3. That's above the line, so it's saturated. NaNO3, that's below, that's unsaturated. Ki's over here. Oh my goodness, what do you think this does? Boy, it keeps going this way. It's going to be below, unsat. Don't overthink these. Don't say, oh, it disappears on here. You can project your line. What if KNO3 solution was heated until all the solute dissolves? So if I have this KNO3 solution and I keep heating it to say about 55 degrees, then it would be saturated. Okay, so if you heat it up, it will dissolve more. Saturated because on the line. Not really that's why, but if it's on the line, that's how we can tell. What temperature allows 70 grams to saturate 100 grams of water of NH4Cl? NH4Cl, NH4Cl, NH4Cl. I don't see NH4. Oh, there it is. NH4Cl. What temperature allows 70 grams? So what temperature allows 70 grams? Here's NH4Cl. Here's 70 grams. Bump. So that is 90 degrees Celsius. Come down. 90. What solutes are gases on the curve to the right? Oops, we mean left. So which ones are going down? we're going down, down, whoops, down, down. So we've got HCl, we've got NH3, we've got SO2. That's it. So let's write those bad boys out. We have HCl, we have NH3, and we have SO2. If I only have 50 grams of water, I'm going to saturate with KClO3 at 80. So I'm going to erase this. Go back to KClO3 at 80. Here's 80. Here's KClO3 at 80. That is 14 grams in 100 grams of water. Okay. So do you see how I went to 80? KClO3, that's about 14. But I only have 50 grams of water equals, this is the proportion thing we're talking about, X over 50. Cross multiply, and 50 times 14, that's what, 90? Oh my goodness, 50 times 14 is 700. Somebody here didn't do the math right. 700 grams equals 100x. So that means 7 grams of KClO3 for 50 grams of H2O. So notice when I set this up, grams of KClO3 and grams of H2O. So notice how the top parts are the same. The bottom parts are the same. By the same, I mean same unit. Okay? To test for saturation. So if I drop in a crystal and it dissolves, it was unsaturated. If the crystal sinks, the solution was saturated. And if extra precipitate comes out, it was supersaturated. Now I've got this. To make a supersaturated solution, overfill, well, yeah, overfill with solute, which means some is on the bottom. 2, heat until solute dissolves. And then step 3 is cool down solution. And ta-da! You have made yourself a super saturated solution. So you cool it down, you'd think the extra would come out, but it doesn't. And with that, we will say toodle.